Yes, good morning, friends. Today I am going to discuss formation of a differential equation whose general solution is given. This is the second video on the differential equations. In the last video, what we are discussing? We are discussing definition of the differential equation, types of the differential equation, and order and degree of the differential equation. Last one is the general and particular solution of the differential equation. These are the 5 parts we are discussing in the last class. Today we are going to discuss formation of a differential equation whose general solution is given. Okay. Now to explain this one, I will take an example here. Here, x square plus y square is equal to r square. Okay. Now what it represents? It represents the equation of a circle whose radius is an r, center is at origin. This represent. Now I will differentiate this one. Differentiate with respect to x. What will get 2x plus differentiation of n y square is a 2y. Again differentiate y is an y dash is equal to differentiation of r square. That is a constant that is equal to 0. Now I will take a 2 common, that is an x plus y into y dash is equal to 0. Then what is an equation 2 represent? Equation 2 represent, it is a family of a circles, family of a concentric circle of the type 1. The equation 2 represent family of concentric circle, family of concentric circle of the type 1. Okay. Now how many times I should differentiate? One time I did. Okay, now I differentiate 1 times. Now I'll take one more example. What is that one? Y is equal to mx plus c. What it represent? It represent an straight line whose slope is an m, whose y-intercept is an c. It is an equation of a straight line. Now I will differentiate this one. Y dash is equal to m is a constant. Differentiation of x is a 1 plus differentiation of c is a 0. Don't need to write. Y dash is equal to m. It is an arbitrary constant. Again I will differentiate. That is an differentiation of y dash is a y double dash. M is a constant. Differentiation of m is a 0. This is equation. What is an equation 2 represent? Equation 2 represent the family of straight line, family of the straight line of the type 1. It is a family of the straight line of the type 1. From these two examples, from this one, these two examples, what I understood means, if it is a one arbitrary constant is there, we have to differentiate 1 times. Okay, now you will get a differential equation. If it is a 2 arbitrary constant is there, you should differentiate 2 times. Using that 2 equations, you have to get an differential equations. Okay, now how many times you have to differentiate, that depend upon the how many arbitrary constant is there in the equation. Okay, now I will take one of the example here. Now, first example, form the differential equation of the family of ellipse having foci on y-axis and the center at origin. Be careful, foci on y-axis, center at origin. Okay, now just ellipse having foci on y-axis. Be careful, foci on y-axis and center at origin. Okay, now center at origin. What is that equation? It is an x square by b square plus y square by a square is equal to 1. Sorry, is equal to 1. Is equal to y x square by b square plus y square by a square, because they given that foci on y axis, center at origin. Okay, na? This is equation 1. Now I will differentiate with respect to x. Differentiate with respect to x. Now differentiation of x square is a 2x. The b square is constant, keep as it is, plus this is a 2y by a square. Again we have to differentiate y, that is a y dash is equal to 0. Okay, na? Now I will take a 2 common. What is left? X by b square plus y into y dash by a square is equal to 0. This equation 2. Okay, na? I told you how many arbitrary constant are there in this. 2 arbitrary constant is there. I differentiate one time. Again I have to differentiate. Next is then I should differentiate equation 2 with respect to x. Differentiation of x is a 1. That is a 1 by b square is as it is, plus 1 by a square as it is. I have to differentiate y into y dash. Then y dash keep as it is. Differentiation of y, again y dash, plus then keep y as it is. Differentiation of y dash is a y double dash is equal to 0. Now 1 by b square keep as it is. I will send this term into RHS, that become minus 1 by a square y dash whole square is there. Y dash y dash y dash whole square plus y into y double dash is equal to, sorry, already I sent this side. Okay. Now this is equation 3. What is an differential equation? The equation which contain the dependent, independent and derivative. If it is an arbitrary constant is there, we have to remove that one. To remove the arbitrary constant, we are doing this process. Just I will substitute equation 3 in where? In the 2. 3 in 2. Then x by, what is the 1 by b square is there? 1 by b square, nothing but this total term is there. Minus 1 by a square, then y dash whole square plus y into y double dash plus y into y dash by a square as it is equal to 0. Okay, now 1 by a square I will take common. I will send that side, that becomes 0. What is left finally? Minus x into y dash square minus x y y double dash plus y y dash, because I took a 1 by a square common and I sent that side, that becomes 0. Now finally I will take in minus common here. What is left? X y y double dash plus x y dash whole square minus y into y dash, because I took a minus common, is equal to 0. This is our required differential equation. Okay, na? It does not contain any arbitrary constant. This is a required differential equation. Okay, na? Okay. In the next class, we will discuss some more example on the differential equation. Okay. Thank you so much. Bye. Take care.